Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. On this occasion, we will try to present one of the materials on the classification of the rapid prototyping system, namely Substractive Rapid Prototyping. This material consists of several subsections, including definition, key characteristic, process sequence, application and example product, and methods. First, let's start with the definition. Subtractive rapid prototyping is one approach to prototyping that contrasts with the additive rapid prototyping methods, such as fuse depositioning modeling, or FDM, or stereolithography, or SLA. In subtractive rapid prototyping, prototypes are formed by removing material from a solid workpiece through a carving or cutting process. This is different from the additive rapid prototyping methods that can build object layer by layer. Here are some key characteristics of subtractive rapid prototyping. 1. Carving or material removal. In subtractive rapid prototyping, a CNC machine or computer numerical control or other tools are used to eliminate unnecessary material from a solid block or workpiece. This can be done using various cutting tools like drills, chisels, or knives. 2. Solid workpiece material. This method utilizes solid workpiece material, typically metals or plastics that are ready to use in a solid form. Unlike additive methods that use material in the form of powders, liquids, or thin sheets. 3. High accuracy. Subtractive rapid prototyping is often known for its high accuracy due to precise material removal or cutting process. This makes it suitable for producing components that require tight tolerance. 4. Waste material. One drawback of subtractive rapid prototyping is that a lot of material is lost during the process, which can result in waste and increased production costs. This is the different from additive methods, which often produce less waste. 5. Slower process. The process of carving or cutting materials usually takes more time compared to additive methods, which can rapidly build object layer by layer. So, subtractive rapid prototyping is often used for prototyping that requires a high level of accuracy or for producing smaller components with harder material. It can also be used to create objects from material that are difficult to print using additive rapid prototyping methods. However, it's important to note that using solid materials and the machining process can be time-consuming and require expensive CNC equipment. The next is the subtractive rapid prototyping process involves a series of steps to turn from solid workpiece materials into a prototype object. Here is a common sequence of this process. 1. Prototype design. The first step is to design the desired prototype using computer-aided design or CAD software. 2. Material section. Choose a suitable material for your prototype needs. Common materials used in subtractive rapid prototyping include metals such as aluminum, steel, or copper, or plastic such as acrylic or delrin. 3. Workpiece preparation. Cut or shape the workpiece material to match the required dimension for the prototype. This may involve cutting metals, block, or plastic sheets into shapes closer to the final design. 4. Processing design into CAM format. Convert the CAD design into a format that can be used by CNC processing equipment. This involves generation G-code that will control the CNC equipment's movement. 5. CNC programming. Program the CNC equipment, milling or cutting machines using the created G code. This will guide the equipment in executing a series of movements to remove unwanted material according to the design. 6. Cutting or carving process. Commence the cutting or carving process of the material based on the CNC program created. The CNC equipment will precisely move cutting tools such as drills, chisels, or knives to gradually remove material as per the design. 7. Cleaning and finishing. After the cutting process is complete, the prototype may require additional cleaning and finishing. This might involve sanding, polishing, and additional cutting if necessary to achieve the desired accuracy and appearance. 8. Testing and evaluation. Prototypes resulting from subtractive rapid prototyping should be tested and evaluated to ensure they meet design specification and desired quality criteria. 9. Finalization and reporting. Once the prototypes are deemed to meet requirements, they can be stored and used in future product development or employed for other project needs. So, the sequence of subtractive rapid prototyping process can vary significantly depending on the type of the workpiece material, design complexity, and the CNC equipment used. It is important to have a strong understanding of CAD or CAM software and the ability to operate and program CNC equipment to be successful in this method.
Okay, Tony, I will continue in this discussion. Next, subtractive rapid prototyping commonly used in various industry to create prototyping or final production component. Here are some applications or an example and product for subtractive rapid prototyping. 1. Aerospace application manufacturing aircraft component, mold and flight test equipment. Example product: turbine, aircraft wing, pilot training, and molding. Next, automotive application prototype of engine, interior and exterior component production and tool. Example product: engine casing, instrument panel, and gear. Next, manufacturing and mass production application product of light titanium component production mold. Example product: machine component, plastic injection mold. Next, renewable energy application manufacturing component for wind turbine, solar panel, or renewable power generation system. Example product: wind turbine blades. Example wind turbine blades, solar panel, organization system component. Next, medical and healthcare application creating anatomic model and human body custom medical device. Example product: air medal, automatic implant, and statutory aid. Next, for digital and development application prototype new product, testing functionality and ergonomy. Example product: electronic product design model, health tool prototype. Next, architecture and construction application creating architecture model and building prototype. Example product: building model, landscape mock-up. Next, education and research application is teaching and demonstration and research prototype. Example in product is education model, research tool prototype. Next, creating education and art application is creating work of art and decoration. Example product: sculpture, art installation, and equipment accessory. As example demonstration of feasibility and subtractive rapid prototyping in aerospace sector, from aerospace and automotive in healthcare and the art. It allows for the achieving accuracy of prototyping and component with precision and accuracy, making it a valuable tool in product development and manufacturing. Next, here are among common subtraction rapid prototype method and method used to creating prototyping or component by removing material from solid workplace material. And one, milling. Milling is an SRP method that uses cutting tool atau or cutter to remove material from the surface in solid workpiece material. Cutter can cut or move linearly to shape object. And next, turning. Turning is method where the workpiece in the rotate arrow and center axis with cutting tool cutter. There are moved to remove material from the outer part to create cylindrical set component. Next, drilling. Drilling involves to the as drill bit the flat hole and grab in power wave. This is component SRP used to create channels or necessary holes. Next, grinding. Grinding using friction between an abrasive tool and the workpiece surface to remove material and height tolerance. Next, electrical discharge material. Next, electrical discharge machining. Or ADM. ADM involves using an electrical current flow between its plate and the workpiece to remove material on the workpiece surface. As application for full to machine material. Next, laser cutting. In this method, a powerful laser is used to cut or engrave material on the workpiece electric for heat sensitive material. Next, abrasive jet machine atau AGM. AGM use high pressure in air or gas mixed with abrasion to remove material from the workplace surface. Next, ultrasonic machining atau USM. USM this ultrasonic weapon to generation and preparation to remove material from the workplace surface. Next, water jet cutting. High pressure water jet cutting involves using a high pressure water jet to cut material on the workplace. Next, chemical cutting and chemical machining. This method involves using chemical reaction to remove material from the workpiece surface. Next, electrical distraction grinding atau ADG. This method combination element of ADM with conventional grinding to active high activity. Okay, great. It's all in material discussion that can brief about subtractive rapid prototype or SRP. If there are mistake, omissions, or previous feedback, please add them in the comment section. Thank you and see you next time. Bye bye.